Hello friends, so this is a follow-up video from my last lecture. So if you remember, we were designing BLC. So these were our, wait a second, so we were designing VLC and these were our design equation, and we have said like we are just taking this design equation and we are not deriving it because deriving it will take some time as we are doing simulation, so we are not deriving it. But in future I'll surely do some lecture where I'll derive this equation using even and odd analysis. But for now we are curious about verifying our result with the theory result which we have got in our last lecture. So let's review those results once again. So okay, let's skip it. So this was our question, like we wanted to design a 10 dB branch line coupler, and I have said 10 dB means it's your C. Means for any BLC question, our first step is to find the value for C. If we get the value for C, then our actually main work of our question is done, because after that, using our design equation, using the lossless condition, we can get one term one after another. So main thing is like designing like deriving the C equation. For example, if somebody say you this is your VLC and I want 25% power in this port and rest of 75 power in this port, then you should get the design for this VLC. So what you do, you just convert this 25. What is this? This is actually your C. So this is the magnitude of C. So you just need to get derive your C. So C will be here 0.25. Okay, so we need to get the C. Like if somebody say you I want a half power division, like 50% here and 50% here, so that means your C is 0.5, or in dB sense it is 3 dB branch line coupler. So you are getting the point now. Like our main objective is always is to get the value for C. Okay, so let's just revive what we have derived in our last lecture. We derived C is equal to 10 dB. We have three design equation, and after that we just got our S11 to be 0.316, our S21 to be 0.949, and we need the impedance. To design the VLC, we need the impedance, and impedance are ZOA as 47.45 and ZOB as 150 ohm. So these are the crucial information, because in the serenade design we need this thing. This thing we don't require in our serenade, but these are the thing which will carry forward to our serenade design. So remember this thing, we'll use this. And and L also. So L lambda by 4 means E equal to 90 degree. I have derived this in my last lecture, so if you haven't seen the last lecture, just go to that lecture and you can find it out. So we have three things. We want E and we want these two things, and we are good to go with our serenade design. And this is what we want to get after the serenade simulation is get over. So let's open serenade. So here is your serenade for you. So what we need, we need to get our transmission line. So go to tools, transmission line, press OK. So and we are designing it for 5 gigahertz, I guess. We don't need to specify the unit because units are already there. Z0 is 47 for the first one. Let me see once again what is that. For ZOA it is 47.45. See, for this branch we need 47.43. Here it is written 43 and it is here written 40. They are quite similar, no issue. So we'll take this one, 47.43. 47.43. Our E should be 90 and it is in degree. Everything is over. H and L in the question is not given, so let's take H 3 millimeter, and our required means ER, epsilon R or dielectric constant to be 2.2. Synthesize, and we have got the thing, and let's import this transmission line to our schematic. We also need to have the information for substrate, and substrate will be same for all the transmission line. We'll have one transmission line here, another transmission line here, and then the legs, 4 legs. But for all the transmission line, substrate will be same because we are fabricating it in top of same substrate. Okay, so let's copy it. I think copy will work. Yeah, because these two are same, so I'm copying it. Okay, now let's go to your transmission line again and design for 151 because we need this also. 150 and 5 gigahertz, synthesize and get it here, reverse it and Control C, Control V and get it here. Now we need to connect it, so get your wire. So connection is done. Now we need the leg part. So leg part will be of reference 50 ohm. So 50 and length could be anything, no issue because they are only the connector. So for us, let it be 90 only, no issue at all. Synthesize and get the thing. Now important part, just keep in mind we are getting to have our ports. So port, like if I select first port, it will be named as port 1. After that, if I select another port, it will be selected as port 2. And for us, this is our port 1, this is port 2, port 3 and port 4. So we need to keep this what is called chronology as same. Otherwise, result will be perfect, but if we want to know the S21 as of our that question, then it will be kind of wrong. So you just keep this thing in your mind, like this is port 1, so this should be port 1, like first one. So port 1, say 50, port 2, 50, port 3 and lastly our port 4. Again get the wires, so done. Lastly, we need to have a frequency generator. We want to see it for 5 gigahertz. So let it be, Control Z. Let it be from 2 gigahertz to 7 gigahertz because 5 will come between. So we can see it, and let's decrease the steps to smoothen our curve. Okay. So hopefully, I think I have done it. So let's analyze it. If some error occur, then pop-up will come. Perfectly, we have not done any error. Then go to report and report editor and see. After clicking here, click S, so all the S parameter will come automatically. So we have this, we have 16 X parameter because in the last class we have seen that our matrix, S matrix for VLC will be of 16, 4:4. So we are getting the 16. So what is our main aim to see? We want to see coupling coefficient. Sorry, it is not responding as I expected. So we want the coupling coefficient, and in the question it is written your coupling coefficient should be 10 dB. So coupling coefficient means S31. So let's select S31, dB, add and display. In display at 5 gigahertz it should be 10 dB, minus 10 dB. So let's see it display. Let's have a data marker. At 5 it is not coming, but no issue. See, okay, let me at 5.02 gigahertz it is minus 10 dB, means we have achieved our coupling coefficient. Control Z, I think Control Z won't be working here. Exit marker, I can't delete it, so let me remove it. Okay, so let's see, from here to here coupling is done. From here to here, let's see what is this. And in our question we have derived it as this was S31. So 20 dB of this will be 10 dB, and 20 dB of this I don't know how much. If you calculate it, then let's calculate it. So it should be 20 log 0.949, and it's coming around minus 45 dB. So let's verify it here. report editor, and it is S21. So S21 dv, and let's delete the previous one, delete, and add and display. At 5 gigahertz it should be 0.45 minus 0.45 data marker, and at 5 gigahertz see we are getting around 0.46. like it's okay, it's minus 0.45 only because I am unable to select the 5 gigahertz exactly, so that's why. So we are correct, we are in our track, we are doing perfectly right thing. So let's now analyze these things. These should be like isolation should be as negative as possible. So go to your report editor, isolation means 41 dv, add and display, and see at 5 gigahertz it is around minus 150, I guess. So we are correct. Let's see for return loss also. So go to your report editor, return loss is S11 because our port 1 is our input port. So go to S11, add and display, and this green curve is your S11, and S11 is also in minus 180. So it's well and perfect. And let's do one thing also. Let's in our report add S31 also. We have seen it earlier, but let's see it in together, like how these four are displayed together, and display, and see this is your S31, I guess. S31, why is S31? Yeah, this color, this is pink color. You just differentiate between pink. Okay, let us change the color also. Clicking the yeah, you can change the color. So let's make it to blue. Perfect. Apply. Sorry, control Z, let it be white only. Actually I have selected the background. Actually I wanted to select the curve, I'm unable to select it. Yeah, now so let it be blue and apply. No, blue already has come already. Light one, apply, close. So see, this is your S31, this is your S21, red is your isolation, and green is your S11, and this is exactly similar to our this present in our theory, like we wanted to get this thing, and this is for actually 3 dB. So that's why both the curve in half power means they are similar, but here we have did it for 10 dB, so that's why there are some gap. Okay, so for this video, this all like video will get over here, and in my next video I'll try to get something for even and odd. I'm not promising it, but I'll try to get even and odd analysis. Okay, till now, bye bye and take care.